Welcome to this lesson. Today I want us to look at gradients and equations of straight lines. This is a Form 2 topic, the fourth topic actually. And the first lesson we are going to look at what is gradient. Now, gradient is another name for slope. I think you have once described a hill and we say maybe this hill is steep or this it is lower steep depending on the way it appears. So we can say gradient is another name of slope. I think you understand what is a slope. And we can use a line here. I can be able to show you what a slope is. So we say this is the ground, and we have maybe you can say a wall here, which we can say like is this a wall. When we are constructing, we normally use a ladder, and therefore we can say this is a ladder 1, 2, 3, 4, 5, 6. So we say this is 1, 2, 3, 4, 5, 6. So what we do is 1, 2, 3, 4, 5, 6. We use that. So this is our ladder. So this is what we are referring to as slope. That is a slope, which is the same as we can be able to use to calculate the value of the slope, which we call the gradient. So the gradient represents the slope mathematically. If we draw another slope here, let's say that is the wall, that is the same wall here. We have the same height. But now we have 1, 2, 3. Let's draw a slope here. 1, 2, 3. So you can see now that this is the same wall. But now what has happened? The distance here. If we say this is x and this is y. So we can say this is y2. And x2, this is x1 and y2. You can see the slope is the two slopes are different. This one is steeper. So this is a steep slope compared to this one. So it means that the mathematical value of the same are different. So how do we calculate the gradient? We say gradient is a ratio of the vertical distance and the horizontal distance. Right? So which we can say slope, you can say gradient is equals to, or the slope, which we have said is the same as slope, the mathematical value of the slope, we use the vertical distance divided by horizontal distance. Divided by the horizontal distance. So having defined that, so we say now looking at our this is the vertical distance, and this is a horizontal distance. Hope you get that. So if we now use the squares, we can be able to get this is a horizontal distance and this is the that is the vertical distance. Sorry for that. This is the vertical distance. And this is the horizontal distance. I hope you are following that. So how do we get now? So when we use a vertical and the horizontal distance, we will be able to get the gradient, the slopeness of our line here. So here we say gradient, if we use G as a gradient, let me use that. We say gradient is equals to the vertical distance 1, 2, we count the squares 1, 2, 3, 4, 5, 6 is equals to 6 divided by 1, 2, 3 divided by 3 is equals to 6 divided by 3, you get 2. What about this one? The gradient is equals to 1, the vertical distance 1, 2, 3, 4, 5, 6 square unit, you divide by 1, 2, 3, 4, 5, 6, you divide by 6, you get 1. So you see the gradient here, the second gradient, we say that is gradient 1, gradient 2. The gradient, the slope here is higher compared to this slope. This is a steep slope. The gradient is higher than when we have the ratio of the vertical distance and the horizontal distance of this slope. So when the gradient is higher in comparison, it means that the slope is steep compared to the other one. So you can represent now in this lesson, in this topic, you mostly be dealing with the gradient of lines on the Cartesian plane. So let's have a look at how do we get the gradient on the Cartesian plane. Remember in Form 1 you learned about the Cartesian plane, that is the XY axis, XY plane. So how do we get the gradient of lines on the Cartesian plane? Let's do that. So I'm going to use a gradient, the grid here to draw the Cartesian plane. So we'll start by drawing you can either maybe when you get used, you don't need to draw the lines, but for now let me just draw the XY axis. So we have that is the X axis and this is the Y axis. Not like that, but let's have it straight like that. So that is the X axis. Always remember to label your axis. So we have that is the Y axis. So this is the Y axis and this is the X axis. We can say this is 1. We label 2, 3, 4, 5, 6, 7, 8. We have 1. This is 0, 2, 3, 4, 5, 6, 7, 8. Like that. Then I'm going to draw a line from the origin, that is 0, 0, and my line would be like that. Let's say that is the line. So this line, we have the coordinates. So what we do is let's pick that point. So that point we call it A. If we drop a line here which is perpendicular to the x-axis, excuse me, from what we have learned in the previous page, this is now is let's say this is a vertical distance, and from there we can get the coordinates of A. In Form 1 you learned about the coordinates. So the coordinates here is, this is 8, so here we have 8 and this is 6. So those are the coordinates of A. Let's say this is O, the origin, and the coordinates of the origin we know it is 0, 0. So we can be able to see clearly here the value of x here is 8. So what we do is How many units squares are here? 1, 2, 3, 4, 5, 6, 7, 8. So these are 8, and these are 1, 2, 3, 4, 5, 6. These are 6 units, square unit. So we can come here and say gradient. We said it is a vertical distance. The vertical distance is 6 divided by the horizontal distance, which we found is 8. And when you simplify here, you divide by 2 is 4, by 2 is 3, so you get it is 3 over 4. That is a gradient using now the vertical distance and the horizontal distance. How do we now make use of the coordinates which we have to be able to calculate the gradient? So we can come here and say the gradient here, gradient is, we say, change in y-axis divided by change in x-axis. What does that mean? Change in y-axis, it means y has changed. At this point, y is 0. Y is 0. It has changed from 0, 1, 2, 3, 4, 5, 6. From 0 to 6. So we say y has changed. You subtract 6 minus 0. Divide by y has moved from 0 to 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. So to get the change in y, the change in x, we say it is 8 minus in the initial point, minus 0. It is equals to what? It is equals to 6 divided by 8, which is the same as when you simplify, you get 4, you get 3. So you get 3 over 4. So you can see for both, we got the same. We got the gradient is the same. So when you are using the coordinates, we take the higher value of y, you minus the lower value, and you take the lower, divide by the higher value of x, you minus the lower value of x. And even if you start with 0 minus 6, divide by 0 minus 8, you still get the same. That is, we can say gradient is equals to, if you start with this, it doesn't matter which point you start with, you say 0 minus y has changed from 0 to 6. So 0 minus 6, you divide by x has changed from 0 to 8. 0 minus 8, so you get it is minus 6 divided by minus 6, minus 8 rather, not 6, which is equal, minus divided by minus will give you positive, so you still end up with 3 over 4. So that is how you get you. So even if you are not a diagram has no, you don't need to draw a diagram of the line, or you plot the line so that you calculate the gradient. As long as you have been given the coordinates, you can be able to get to get the gradient of a line, and we are going to see more of that. That is, how do you calculate the gradient of a straight line using the coordinates. But I have demonstrated using the Cartesian plane how you calculate, how you get the gradient of a straight line. So next, let's have a look at example. Before I conclude that, it is important to note that as the gradient of a straight line does not change. Maybe I show you that how that is. Let's see, we have used this point and this point. What about if we use another point to calculate the gradient? So let's see how whether the gradient remains constant. In the previous change, we have calculated the gradient of this line using these 2 points, 0, 0, 0 coordinates and 8, 6. Now, I have stated, and that is what I want to demonstrate, that the gradient of a line, of a straight line, is constant. Constant means it doesn't change. The gradient at this point is the same gradient at this point, as long as it is a straight line. How do I demonstrate that? I am going to use this point, and I'm going to pick another point here. That is a point. So let's say this is point B there. The coordinates of point B, x is 4, and y is 3. So we have now a is let's remove this. So we have a, the coordinates of a are 8, 6. The coordinates of b are 4, 3. Coordinates of b. How do we get the gradient? Gradient is equals to, we have said it is change in y divided by change in y divided by change in x, can say axis. Okay, so if you look at, and we have said it doesn't matter whichever coordinates you start with, but it's always good to start with a bigger value of y and the bigger value of x. So this is equals to, so y has changed from 6 to 3, or from 3 to 6. So we say it is 6 minus 3, you divide by, x has changed from 4 to 8, so we say it is 8 minus 4. So this is equals to 6 minus 3 is 3, and 8 minus 4 is 4, which I have clearly demonstrated in the previous page. We got the gradient is 3 over 4 using the point 0, 0 and 8, 6. Here the gradient has remained the same. It is 3 over 4, where we have used the two coordinates of a and b. B is 4, 3, 8 is 8, 6. So you can see that demonstrates the fact that the gradient of a straight line remains constant as long as you identify any 2 points. If you use this, you can try calculate the gradient of this line using O 0, 0, and using B, which is 4, 3. See whether you still get the gradient as 4 over 3. So you can check that. So that is how we calculate the gradient of a line. And now you understand another name of slope is gradient. A gradient, we can be able to calculate the slopeness of a line by using the coordinates. That is that is change in y, that is the vertical change, the ratio of vertical change divided by horizontal change, which is the same as change in y-axis divided by change in x-axis. So let's have a look at a few examples on how we calculate the gradient before we move to the we look at one example of how we calculate the gradient before we move to something else. So this is the example 1. Find the gradient of line AB in the figure below. So we have the Cartesian plane. You can use your mathematics book. If you don't have a graph paper, you can just use your ordinary mathematics book. You draw this Cartesian plane and the line which passes through 3, 0, 3 and minus 1, 0. So if you use a ruler, you draw a line, you'll be able to get that. To get the gradient, how do we get the gradient? We have said that gradient is equals to y-axis, change in y. We can use that symbol to represent change in y divided by change in x. So this is the same as change in y divided by change in x, where we have said change in y is the same as the vertical distance, and change in x is the same as so this is a change in y-axis divided by change in x-axis. All right, so it is important. So this is a short form of the triangle here is the same as change in y x-axis and change in x-axis. So how do we get the gradient? Gradient is equals to we say that we will be able to use the coordinates to be able to get the gradient. So if you look at our lines, we look at 2 points where the line we can be able to get definite coordinates. We can use this point here. This point let's call it M, and the coordinates x is 1 and y is 6. So we can use that. We can use this point, we can use this point, or you can use this point, any of the point, because we have said, I have said earlier that the gradient of a straight line is constant, so it doesn't change. So whichever 2 points, as long as it is a straight line, then you should be able to get the gradient. So let's say this is our n. So the coordinates of n are y is 0 and x is 0 and y is 3. That is x is 0 here and y is 3 there. So we can be able to use these 2 points to get the gradient. So what is the change in y? We say it is 6, the upper coordinate of y minus the lower coordinate of y. So this is 6 minus 3. You divide by 1 minus 0. 1 minus 0. So this will give you what? This is 3. 6 minus 3 is 3. Divide by 1 minus 1 is 0, which should give you 3. Anything divided by 1 is the same as the starting. So 3 divided by 1 is the same as 3. So that is the gradient of this line. We have used the 2 points and we have obtained the gradient. So that's how you get the gradient of this line. I can demonstrate further that the gradient of this, you can use any other 2 points and find whether the gradient is the same. Let's use that point. Let's say that is that point is P, and we have the coordinates of P. Coordinates are x is minus 1 and y is 0. So this point here, maybe if I use a different color, that would be a bit better. So I'm going to say that is a point, our P, and this is the value of x is 1 minus 1 and y is 0. We use another point here. The value of x is let's say this is Q, and our point Q, the coordinates are x is minus 2 and y is minus 3. So let's check whether the gradient is, you can use this space. The gradient is equals to, now this is, we can start with this one, 0 minus 3. We just say we can start with this one, minus 3 minus 0. Divide by, we have started with 3, so we start with minus 2 minus the other one is minus 1. So you can write it like that. So this is equals to minus 3 divided by minus 2. Minus and minus will be positive. So this will be minus 2 plus 1. Because when you multiply minus multiplied by minus, it will give you positive. So this means that this is minus 3 minus 2. Minus 2 plus 1 will give you minus 1. Minus and minus, when you divide a minus and a minus, you get positive. So positive 3 divided by 1 is equals to 3. So you can see that this gradient is the same as, so as long as you have 2 points and it is a straight line, the gradient is the same. The gradient is constant. That's the right word. The gradient of a straight line is constant. It doesn't change. That you calculate the gradient here, even if you use these 2 points, that is this point and this one, you still get the gradient is equals to 3. I think that demonstrates clearly that the gradient of a line is constant. So whenever you only need 2 points. Once you are given, you have the coordinates of 2 points, you should be able to get the gradient. I hope that one is clear. Now let's move on, and before we conclude the lesson, find out when is a gradient positive, when is it positive, when it is negative, when it is a constant, and when it is undefined. And that's what we are going to do next. Now in this section, there's something that I want to show you. We have gradient. We have 4 lines here. Let's start with this one. A, choose we say this is A and B. Now if you look at line AB, when when there is an, let's say take this point, that is minus 1 0, x increases to this direction. As x increases, the y also increases. So when x moves to 1, we have y slightly above 1. Like we take this point, x has moved from minus 1 to 5. Y has moved from 0 to 4. So we can say this is minus 1 0, and this is we take this is point is 5 and 4. So what has happened? X has changed from minus 1 to 5. Y has changed from 0 to 4. When we have an increase in y, both increase in y, that is when x changes, increases, and y increases, the gradient is positive. Gradient, so here, because both x and y increases, we say that the gradient is positive. So that is, and you can say that the line is slanting from left, that is slanting from right to left. So that the gradient is, whenever you have a line that is slanting in this form, or when the increase in x causes increase in y, the gradient is positive. We come to this line here. I'll label it as PQ. This is PQ. So we can take 2 points. Let's take that point. The gradient, the coordinates at that point are minus 7 and the y is 4. We can take another point like this point here and say this is y, that is x is 0 and y is 1. So you can see this is 4. What has happened? X has x has increased from minus 7 to 0. That is an increase from the negative direction towards 0. So there is an increase. But y has decreased from 4 to minus to 1. That is from 4 from here to here. But x has increased from minus 7 to 1. So when there is an increase in x axis causes decrease in y axis, we say the gradient is negative. Gradient is negative. That is any line slanting like this, like this, like this, all these lines, their gradient will be negative. Their gradient will be negative. All lines slanting like this, the gradient is positive. That is what we mean. Then we come to the another line here. We can call it MQ or MN. Let's just call it NM. So you can see here, for example, if we take that point, this will be minus 6 and 5. If we take this point, it is 4, but y remains 5. So there is a change in x, but there is no change in y. So like if we were to calculate the gradient of that line, we would say 5 minus 5 divided by 5 minus 6 minus 4. So this will give us 0 divided by minus 10. 0 divided by any number is equals to 0. Okay, so this means what we mean by this is that any line that is horizontal, that is no change in y, the gradient is always 0. Any line that is horizontal like that, any line that is horizontal, the gradient is always equals to 0 because there is no change in y. Then we are going to have another line here that is vertical like that, and we can call that line, let's call it P we have PQ, we have AB, then we can call it S and T. S and T, we can take any 2 points. We can take that, or we can take just take this point here, which is 7. That is which is 7. X is 7 and Y is 1. We take another point here, like where we have T. X is 7, but Y has changed to 7. You can say this is 7. Now, what has happened? If we take these 2 points, we say gradient is equals to change in Y. We can say 7 minus 1 divided by 7 minus 7. Change in X. There is no change, so it's 7.7. So it is 6 divided by 0. When you divide anything by 0, we say it is undefined. Or it reads to infinity. So when we have a vertical line, that is a vertical line like this, then the gradient will always that is perpendicular to the x-axis like that. The gradient is undefined. So that's what I wanted to clarify, and it is very important that you note that when we have that gradient, then we say this gradient is undefined, because x is not changing, so we end up dividing by 0. And when you divide by 0, then we say we can't divide by 0, or it is undefined, or it reads to infinity. That we don't have the gradient, we don't have any slope here, because a slope is when it is like a line is bending to an angle. So very important. Let me repeat: any gradient that is slope that is change in x causes change in y, that gradient is positive. The gradient where when we have an increase in x, it causes a decrease in y, that gradient is negative. When we have a horizontal line, the gradient is always equals to 0. And when we have vertical lines, so we have perpendicular lines to the x-axis, the gradient is undefined, and that is very important for you to note. So we have these lines, for the 4 lines: AB positive, we have PQ negative, we have MN 0, and we have ST undefined. Very important to note that. Now that brings us to the end of our lesson. So let's have 2 or 3 examples, and then we can conclude the lesson. Here is an example. We have lines here. We have the Cartesian plane, x and y, and we have lines here, some slanting this way, others this way, others parallel to the x-axis, and others parallel to the y-axis. So I want you to group that is let's group the lines, i.e. the lines positive that have 1, that is 1 positive gradient. So we have line 1, L1, line L2, L3, L4, L5. So you group the lines, put together those lines which have positive gradient. The other one have negative gradient. The other one has positive, that is 0 gradient, and the other one is undefined. So I have just talked about that. in the other page. So can you do that? Let's have another example. This is another example. Example 4. Find the gradient of each of the following. So we have y is equals to a half x plus 1, and we have 3y minus 4x is equals to 5. So to be able to do this, we have said that if you know 2 points of a line, of a straight line, then you can be able to get to calculate the gradient. This means that we can use this equation y is equals to a half x plus 1 to be able to get 2 points, coordinates of 2 points. So we'll say when x is equals to 2, or let's just say when x is 0, so we come here and say y is equals to a half multiplied by 0, because we have assigned x is equals to 0, you add 1. So a half multiplied by 0 is 0, so y is equals to 1. Y is equals to 1. So 1 point is, this means that the coordinates of this one of the point is 1, x is 0 and y is 1. That's the coordinate. We do the same. We say when x is equals to 2, you come here and say y is equals to a half multiplied by 2 plus 1. So 2 divided by 2 is 1. So we have 1 plus 1 is 2. So it means that y, when x is equals to 2, y is equals to also 2 when x is 2. So the other point is when x is 2, then y is also 2. We have computed, and now we have 2 points here. So it means a gradient of this line, is equals to change in y. So we take 2 minus 1, 2, this 2 minus 1, and change in x, 2 minus 0. If you start with this one, y minus 2 minus 1, you also start with this x minus 0. So we say it is 2 minus 0. So this is equals to 2 minus 2 is 0. You divide by, no, I think here we have made a mistake. It should be, we are talking of 2 minus 1. So this 2 minus 1, you divide by 2 minus 0. 2 minus 0. So this is equals to 2 minus 1 is 1. You divide by 2 minus 0 is 2. So the gradient is a half. So that's how. So you first of all have to look for 2 points. 2 points, and then you'll be able to, when you get 2 coordinates of 2 points, then you'll be able to get the gradient. The other one is this one. 3y is equals to 4x. So how do we get the 2 points? We can substitute. Maybe we put x to the other side so that we have 3y is equals to 4x, because when it crosses the equal sign, it becomes positive plus 5. Let's divide throughout by 3 so that we can be able to compute. So you have y is equals to 4 over 3 x plus 5 over 3 plus 5 over 3. Now when you have that, how do we get the gradient? The gradient here, we can be able to say, let's use a value we can be able to get rid of these 3, or we just say, what about when x is equals to 1? So we say y is equals to 4 over 3 multiplied by 1, that will remain the same. Then you say plus 5 over 3. So when you add, this means this is equals to, divide by 3, this will be 9. 4 plus 4, the LCM is 3, so that will be 4 plus 5 is 9. You divide here, you get 3. So it is equals to 3. So when x is 1, y is 3. So one of the coordinates is, you have it is 1 and 3. 3. Then we get another point. Let's say we try 3. So we have y when x is equals to 3, then it means y is equals to 4 over 3 multiplied by 3 plus 5 over 3. So what will that give you? So 3 and 3 will cancel. So this will be, this is 1 and 2/3. 1 and 2/3. So that will give us 5 and 2/3. So this means that when x is the coordinates, when x is 3, y is 5 and 2 over 3. Now we have this. Now we now have we have this point and we have this point. So once you have 2 points, then you should be able to get the gradient. So gradient is equals to change in y. So y changes, we can say 5, that is 5 and 2 over 3 minus 3. You divide by change in x, 3 minus 1, 3 minus 1. So this will give you, when you substitute 3 here, it will be 2 and 2 over 3. You divide by 2, which you can say this is equals to, let me do it here. This is 3 multiplied by 2 is 6. 6 plus, so that is 8 over 3. You divide by 2, so it means you multiply by, this is the same as, if you divide by 2, it's, that is, let's say, we say divide by 2, because 3 minus 1 is 2. So it's the same as 8 over 3. You multiply by 1 over 2. Divide by 2 is 1. Divide by 2, you get 4. So this means the gradient is equals to 4 divided by 4 multiplied by 1 is 4 divided by 3. So that is a gradient. So when you are given in this format, you rearrange that and you'll be able to get the gradient. So you rearrange your equation so that you have y on one side, and you can get two values, which when you substitute, you'll be able to get 2 points, coordinates of 2 points. Then using those 2 points, then you should be able to get the gradient. Let's have one more example. This is example 5. Find the coordinates of the other point if, this is if, you are given the coordinates of one point and the gradient. So here we have A. You are given 1 point is 1, 2, the coordinates of 1 point, and the gradient is 5. You are required to find the coordinates of the other point. And how do you do that? So what we do here is we take A. To find the gradient, we say it is change in y and change in x. So we can say if one of the coordinates is 1, 2, let's say the other coordinates is x and y, and gradient is equals to 5. So what we do is we can say to get 5, we say y minus 2 divided by x minus 1 should give you 5. So cross multiply. So we say y minus 2 is equals to 5 x minus 1. Y minus 2 is equals to 5x minus 5. You open the bracket here. So take 2 to the other side. Y is equals to 5x. When 2 crosses the equal sign, it becomes positive. So it is minus 5 plus 2. So y is equals to 5x minus 5 plus 2. That will give you minus 3. Now we have the equation. So we can say to get another point, we can say what about when x is 0? So we can say when x is equals to 0, then y is equals to it is equals to 5 multiplied by 0 minus 3. That will give 5 minus times 0 is 0. minus 3, you get minus 3. So another coordinate is 0 and 3. 0 and minus 3, sorry. 0 and minus 3. So with this, if you use this point here, coordinate here, and this one, you still get the gradient is 5. Let's go to the second one. Now we say, just like we have worked out this one, we say when x, we are told that this is, so we say we have 0.5 and 0.5, the gradient is 0.5. So we say the other, why don't we let the other point be x and the y, x, y, that is x and y. So we say y minus 0.5, change in y minus this, divide by x minus 0.5 is equals to 0.5. Cross multiply like we have done here. So y minus 0.5 is equals to 0.5. You multiply by x minus 0.5. So open the bracket here, you have y minus 0.5 is equals to 0.5x. 0.5 multiplied by 0.5, it will be minus this is minus 0.25, minus 0.25. Take minus 0.5 to the other side, becomes positive. So we have y is equals 0.5 x minus 0.25 plus 0.5, because it changes. So you have y is equals to 0.5 x minus 0.25 plus 0.25, that will give you positive 0.25. Now, like we have substituted, we just say when we can still say when x is 0, when x is equals to 0, so we multiply here by 0, y will be 0.25. So the other coordinate is when x is 0, y is 0.25. So that is the other coordinate. If you use this coordinate and this one, you still get the gradient is 0.5. You can try that and tell me whether you get that in the comment section. I'll be able to see. If you don't get that, then I'll be able to advise you how to go about it. Lastly, we get, I think that should be enough. So I'm going to give you 2-3 questions. You try and you give your answers in the comment section. I'll be able to check what you have got. So you can pause the video, write the question, work on them, post your answer in the comment section. I'll be able to see what you have done. You can also take a photo of what you have done and send it to me. I'll send it to put it in the comment. I'll be able to see whether you have followed what we have done. So let's do that. So this is what I want you to do. I have given you these around 3 questions. You can do them, post your answers in the comment section. So the first one, for each of the following pair of points, find the corresponding change in y coordinates and the corresponding change in x coordinate, hence find the gradient of the line passing through them. So I have shown you how to find the gradient of a line given 2 points. So that should not be difficult for you. You can pause the video and copy the questions, then you can do it later. The other one is find the gradients of the lines passing through the following pairs of points. So we have that point and that point, you find the gradient. That point and that point, you find the gradient. Number 3, find the gradient of each of the following lines. So you are given the equation. We have worked out an example or similar to this one. Number 4, given that one point of a line is 6, 1 and the gradient is at that, find the other point. We have also worked on that. So I think you should be able to do that. So that brings us to the first lesson of this topic, gradients and equations of straight lines. So I'll also show you, we move to the second lesson. So click the link below this video. You'll be able to get the second question, the second lesson rather, of this topic. And then after that, you get the third one until you get the end of this topic. So thank you for watching. To benefit more from these videos, subscribe to my channel by hitting the subscription button. You hit the like button, you comment, you share, and you also hit the bell so that you are notified whenever I post a new video. Join my free live online class. Request for any topic or question that you would like me to cover. Thank you for watching.